Alright, here we are with lesson 12. We're going to take a look at linear equations in two variables. So for this lesson you're going to need graph paper. Now let's take a look at the opening exercise. Complete the table and the question after it before continuing the video. Alright, you should have filled in the table and answered the question so we can check our answers. You should have something that looks like this. So to add up the number of 2-pointers and 3-pointers, that would equal 32. You would have something that would look like this. 16 2-pointers would be 32, or 13 2-pointers and 2 3-pointers, or 10 2-pointers and 4 3-pointers, 7 2-pointers and 6 3-pointers, 4 2-pointers and 8 3-pointers, or 1 2-pointers and 10 3-pointers. And again, they could be in any order, but here are some of the examples you could have. So therefore, our equation would be something of the line of 2 times x plus 3 times y equals 32. 2 representing the points for 2-pointers, 3 representing the points for 3-pointers, and the x and y representing how many of those that you make. All right, in your journal, this is where we'll do some note-taking based on the discussion. So first of all, some vocabulary. An equation in the form of ax plus by equals c is called a linear equation in two variables, where a, b, and c are constants, and at least one of a and b are not 0. So in this lesson, neither a or b will be equal to 0. In the opening exercise, what equation did you write to represent Emily's score at the basketball game? Well, again, that was 2 times x plus 3 times y equals 32. So the equation 2x plus 3y equals 32 is an example of a linear equation in two variables. An equation of this form, ax plus by equals c, is also referred to as an equation in standard form. Is the equation you wrote in the opening exercise in standard form? Well, yes, it is the same form as ax plus by equals c. So in the equation ax plus by equals c, the symbols a, b, and c are constants. What then are x and y? Well, the symbols x and y are numbers. Since they are not constants, it means that they are unknown numbers, typically called variables, in the equation ax plus by equals c. So for example, negative 50x plus y equals 15 is a linear equation in x and y. As you can easily see, not just any pair of numbers, x and y, will make the equation true. Consider x equaling 1 and y equaling 2. Does this make the equation true? Well, no, because if you did negative 50 times 1 plus 2, that would be negative 50 plus 2 is equal to negative 48, which is not equal to 15. So what pairs of numbers did you find that worked for Emily's basketball score? Did just any pair of numbers work? Explain. Well, the pairs of numbers in the table of the opening exercise would work, but no, not just any pair of numbers would work. For example, we couldn't say that Emily scored 15 2-pointers and 1 3-pointer, because that would mean she scored 33 points in the game, and she only scored 32 points. So a solution to a linear equation in two variables is an ordered pair of numbers, x comma y, so that x and y make the equation a true statement. The pairs of numbers that you wrote in the table for Emily are solutions to the equation 2x plus 3y equals 32, because there are pairs of numbers that make the equation true. The question becomes then, how do we find an unlimited number of solutions to a given linear equation? Well, you could guess numbers until you find a pair that makes the equation true. However, that's probably not a very efficient way. So a strategy that would help us find solutions to a linear equation in two variables is as follows. First, you want to fix a number for x. That means we pick any number we want and call it x. Since we know how to solve a linear equation in one variable, then we solve for y. The number we picked for x and the number we get when we solve for y is the ordered pair x comma y, which is the solution to the two-variable linear equation. For example, let x equal y, or let x equal 5. Then in the equation negative 50x plus y equals 15, we would have y equals 265. So therefore, 5 comma 265 is a solution to the equation negative 50x plus y equals 15. Similarly, we can fix a number for y and solve for x. Let y equal 10. Then x would equal negative 1/10. So therefore, the ordered pair negative 1/10, 10 is a solution to the equation negative 50x plus y equals 15. So choose two more numbers for x and two more numbers for y and come up with 4 more solutions for the equation. Be ready to share your solutions in class. All right, so let's take a look at some exploratory challenges and exercises 1 through 5. What you're going to do is complete the exercises. Some hints for these are in exercises 1 and 2, small numbers would ease the mental math work. For exercise 3, may be easier if you choose a number for y and solve for x. And exercise 4 can be made easier if you choose values for x that are multiples of 5. When you are done with this, you can go ahead and check your answers, but pay attention to the process for solving. Your answers might be different, but your graphs should all be straight lines. So you might be picking different numbers. So when you check your answers, don't worry about the fact that the numbers you chose might be different, but just worry about the process. Look at the process and practice the process for solving for whichever variable you're choosing. All right, you should be at least on your way to completing exercises 1 through 5, so let's go ahead and go over the answers. So again, making sure that you include the linear equation, what you are adding for each x. So in this case, x plus y equals 3, and you don't have to pick 1 through 5. You can pick any graph or any coordinate for x. And then again, your graph will match whatever your numbers are here. But again, you should have a straight line going from left to right in a downward slope. All right, for part 2, or question 2, again, a little bit more involved on the solving. These take a little bit more process. Again, you didn't have to pick 1 through 5. But you could have. However, as long as you pick a number for x, you should end up with a number for y. When you're done with that, your graph again should look like a straight line, and this time from left to right, it's going in an upward trend. For question 3, a little bit same thing. We have some more work that is involved. Again, depending on what numbers you picked, sometimes you can pick some negative numbers also. 0 is also a good number to pick. But in this case, all these numbers that are picked will equal whole numbers. You could pick different numbers and end up with fractions for y. But notice which numbers they picked to end up with whole number for y. Compare the x's to what the equation is. And again, the graph from left to right is going in a downward slope. So consider the linear equation 2/5 x plus y equals 11. Will you choose to fit values for x or y and explain? Well, if you fix values for x, it will make the computations easier. Solving for y can be done in one step. Are there specific numbers that would make your computation easier? Well, values that are multiples of 5 would make the computation easier. When I multiply 2/5 by a multiple of 5, you will get a whole number integer. Why? Because the 5s will, the factors of whatever number you pick, 5 over 5, would create 1. So that would essentially negate your denominator. All right, for part C, then going ahead and picking numbers like 5, 10, 15, 20, 25 would give you whole number for y, and you can see y here. And the graph, again, going from left to right, is in a downward slope. And last but not least, a word problem. Creating a linear equation, 2x plus y equals 35. The 2x being $2 for a bag of candy and $1, because if you think of it, this would be 1 times y, so we just leave it as y. That represents the drink. And if you were to graph this drinks to bags of candy, you would get a downward slope from left to right. Right. So a two-variable equation in the form of ax plus by equals c is known as a linear equation in standard form. A solution to a linear equation in two variables is an ordered pair that makes the given equation true. And last, we can find solutions by fixing a number for x or y, then solving for the other variable. Our work can be made easier by thinking about the computations we will need to make before fixing a number for x or y. For example, if x has a coefficient of 1/3, then we should select values for x that are multiples of 3. All right, we'll see you in class.